Okay, we are going to start section 12.4 here today. We're going to take a little shift away from looking at right triangles to now trying to solve triangles that are obtuse or acute. I think at this point, all the triangles that we've been focusing on, even those that are in the unit circle, have all been right triangles. We're going to be introduced to something called the law of sines here today. Anytime that you are trying to use any of the given measurements in a triangle to find all of the unknown side lengths and all of the angle measurements, what you're doing is you are solving the triangle. So if the directions ever say to solve the triangle, this is what they want you to do. They want you to find all the missing side lengths as well as all of the missing angle measurements. Okay, so here we have something called the law of sines, and you can see here that we have essentially three fractions here. When you're using the law of sines, you're going to be setting two of these fractions equal to each other. Okay, so we'll just be picking two of these. Now, one important thing to note here is you want to make sure that for these problems that your calculator is definitely in degree mode. We don't want that to be in radian mode. Okay. Now, the law of sines is particularly helpful when the information that you're given in your triangle would be two angle measurements followed by a side that's not in between those two angle measurements. So for example, just to kind of draw on this triangle here, if you knew angle A and say you knew angle B, and then you were also told side A, okay, that's what we call angle, angle, side. Okay. It's also beneficial to use the law of sines if you're given two sides and an angle that's not in between those two sides. For example, let's say you're given the length of side C, the length of side A, and then you're given an angle that's not the angle that's in between those. Okay, so you're going to see that with these examples here today. Okay, so if you see the directions here, they say solve triangle ABC. So we've got some blanks down here. We need to try to find these missing pieces of information. We need the length of side A, side B, as well as angle A here. Okay. So what we're going to go ahead and do first is we should be able to find angle A pretty easily, because one of the things we know about all triangles is that the angles should add up to 180 degrees. If we're given two angles already, we should be able to add up the two angles that we're given and simply subtract that sum off of 180 degrees. That gives us that the remaining degrees would be angle A, 55 degrees. As you find these missing pieces, I want you to add them onto your picture. Okay, now we didn't need to use the law of sines to find that missing angle, but here's where the law of sines come in. Capital letters are going to be used to designate angles. Lowercase letters will represent the side lengths that are opposite each of those angles. Okay, so when you see here in law of sines, it's saying sine of angle A over side A should be equal to sine of angle B over side B. Same thing with C here. Okay, so you want to identify a side and an angle that are opposite each other. So for example, here we know angle C and we know side C. Okay, we definitely want to have a fraction where we know both the numerator and the denominator. So I'm going to set up sine of 80 degrees over 3, and I'm going to set that equal to, and then I can pick one of the other pieces. It doesn't matter which one here. We'll go with side B first. So we're going to fill in sine of, we know angle B is 45 degrees, but what we're looking to find is we're looking to find side B. So I'm basically setting up this proportion right there. Okay, now when I go to solve this, I'm just going to cross multiply these fractions here. So I'll have B times sine of 80, set that equal to 3 times sine of 45, and to solve for side B, I'm going to divide both sides by sine of 80. Okay, as long as you're in degree mode, You can type that into your calculator. We will round the side lengths to 2 decimal places. Okay, so we'll go ahead and do that. I'm just going to kind of clear up a few of the things that I have on my picture here. I'm going to fill in 2.15 units on the blank. And again, as you find these missing pieces, I want you to add them to your picture. Okay, now we have one more side to find. Now remember, this is not a right triangle, so we cannot do the Pythagorean theorem for this. We have to use the law of sines. I'm going to encourage you, though, always use that one consistent angle and side that you were given in the problem, because those numbers were not rounded in any way at all. They were already in the problem. So it's better to use sine of 80 over 3 and now set that equal to sine of 55 over a than to in any way try to incorporate this fraction, because this number 2.15, we actually rounded that. So we want to try to not use that to calculate another missing side. Okay, so we're going to set up sine of 55 degrees. We're going to put that over a, and then we're going to cross multiply. Okay, so I'm going to go ahead and cross multiply here. Okay, so I got a times sine of 80 equals 3 times sine of 55, and to solve this for side A, I'm going to divide both sides by sine of 80 degrees. So again, you would type that into your calculator. We're just going to round to 2 places here. I'm just going to clean up my picture here. And I'm going to add onto the picture 2.50 units is the length of side A, and I'll go ahead and fill that over here into the blank. Okay. It is important that you are showing the work that you see that I have shown right here for these. Okay. I don't want you doing all this work just on your calculator and then you just magically have these answers here with nothing to support how you got that. I need to see the proportions, the fractions you've set equal, and show how you're solving for those missing sides. Okay, let's go ahead and try another one here. Okay, we're going to take a look. On this one, they do not provide the picture for us. So we're going to go ahead and draw a triangle MNP. I wouldn't say that you need to worry too much about trying to draw the picture to scale in any way. Okay, so we're just going to label our vertices M and P. We'll go ahead and label angle N is 32 degrees. Side N is 7, that would be opposite angle N, and side P is 4. Okay. Now, anytime a picture is not provided, you need to always draw a picture. Your answer is you listing any pieces that are missing, angles and sides, and also when you're all the way done, you should have a picture that has all the angles and all the sides filled in. Okay, so I'm looking for an angle and a side that are opposite each other. Okay, there we have that. So that's definitely going to be the proportion that I'm going to use here. I'm going to set up sine of 32 degrees over 7. Okay, now on this one, you can see how up above here I was mentioning that law of sines is best when you're given 2 angles and a side not in between the 2 angles. That was kind of the situation that we had here with the example we just did. Now in this one, we're given 2 sides and an angle that's not in between the 2 sides. You can see here 2 sides and this angle's not actually in between them here. Okay, so what we're going to need is technically this is side M. I don't want to incorporate sine of M over side M because I don't know either of those 2 variables at this point. So I technically need to choose something where at least I know one of the pieces, and it feels like that would be sine of angle P over, we actually know that 4 is side P. Okay. All right, so now on this problem, notice what we'll be solving for. We're going to be solving for an angle. Okay, that's that capital P there. So we cross multiply to begin with here. Okay, the next step, we're going to divide both sides by 7. Okay, now remember back to when we learned how to solve for missing angles using trig functions. How you break apart a trig function from the angle is you have to take the inverse sine and that cancels sine off, leaving you with just p. So that means on this side, you have to be very careful with how you type this in. You're going to be doing the inverse sine of, and then you'll type this in. Okay, now our angles, we're going to round those all the way up to the nearest degree. We're going to round angle P up to 18 degrees. Okay, so I'm going to put that on the blank here. I'm also going to add that onto the picture. Okay, now anytime we know two angle measurements, we can always find the third angle measurement. Again, because we know that every triangle has 180 degrees in it. So our two angles add up to 50. That means if we subtract 50 from 180, that means that angle M has to be 130 degrees. Now you can see that obviously I did not draw this triangle to scale, and it's difficult to do because we don't really know what these missing angles are. Okay, so this is an obtuse triangle, even though my picture doesn't make it look like it is there. Okay, so now that we know angle M, now I know one of the pieces here. I know angle M. I can now set up another law of sines to find side M. And I want you to go back and use what I had highlighted there in yellow. Let's use sine of 32 over 7 equals, now it'll be sine of 130 over M. Okay, we're going to cross multiply. Okay, and then divide by sine of 32. Okay, we'll type this into the calculator. Be really careful when you're typing this in. You know, it often feeds you a parenthesis after your trig function. Make sure you always close that parenthesis up on the other side there. This should give you side M to be roughly 10.12 units. So again, let's add it to the picture. 10.12 units, and let's place that on the blank there. Okay, we're just going to run through one more very quickly here on the back. Okay, again, a picture's not provided, so we're going to go ahead and just sketch a picture here. This is triangle NPQ. Let's add what we're given to the picture. Angle P is 42 degrees, angle Q is 65 degrees, and notice that we're given side N, which is 5. Okay, now at first glance, this feels like the information we're given is an angle with a side in between another angle. And that actually wasn't one of the situations that I expressed here for law of sines, but that actually would work. Okay, now let's take a closer look at this picture here. We know when we're doing law of sines, we need to know one angle and one side opposite that angle. Well, we only have one side to work with. That's side 5. Now, at first glance, it feels like we don't know the angle opposite side 5. But if you look closer, they gave us two angles, 42 and 65. So if we add those up, and then subtract that sum off of 180, we technically do have what angle N is. So that would be the first thing that we would solve for. We don't need to use law of sines to get that. Okay, once we have that, then we can set up, that's going to be our kind of our base fraction we're going to use. Sine of 73 over 5 equals, and I could pick either one of the other two options to go with. We'll just do side P first. We're going to do sine of 42 over side P. Okay, a quick cross multiply here. Okay, we'll divide by sine of 73. Okay, again, very important that your calculator is in degree mode for this. Let's go ahead and add onto our picture the length of side P. We'll add that onto our blank as well. Now, one thing I should mention, is make sure when we go to find the last side Q, okay, side Q, let's revert back to making sure that we are using the original fraction sine of 73 over 5. And here's why. it's better to use this fraction paired with trying to find side Q than this fraction, because this side length, 3.50, remember where we got that from? We got that from typing this in. We actually rounded that number. It's better if we can stay away from making a calculation for a number using a number that we have rounded. So that's why I'm going back and still using sine of 73 over 5. That's going to be equal to sine of 65 over side Q. Okay, one last cross multiplication here. All right. Okay, and this is going to give us side Q, if we round this, is 4.74. So I'm just going to put that on the picture and put that on the blank. Now, your worksheet tonight is, it might actually be called worksheet 12.4 A and B. Okay, there are 6 problems on it, but I only want you to do the odd problems. So you're just going to do problems 1, 3, and 5. And we will save the evens after we talk a little bit more about another element to this law of sine. So only do the odds on that worksheet.